welcome back to the IJS Online Edition. My name is Dominic Muhilo and I am editor for the German Java magazine and jugcenter.com. The following session is about implementing event sourcing in Node.js, and it is held by Tamar, software manager and architect. Before I give over to Tamar, just a little bit of information for you guys at home. You can use the chat and swap card to get help by our technical staff if there are any problems, but you can also use it just for chatting and commenting on the session. You can also ask questions via the integrated Q&A tool or via chat. And if there's time at the end, Tamar will answer the questions after her session. If there's no time left, we will prepare probably a little Q&A overview on the conference blog and jugcenter.com with the unanswered questions. And with that, I am very pleased to announce Tamar Stern. Hi, Tamar.
Hi, how are you, everyone? Shall I start?
Yes.
All right, so I guess I would share my screen. Just give me a second. Hi, everyone. I'm very, very excited to be here at the first edition of the International JavaScript Conference online edition. I am going to share my screen. And we're going to start talking about a lot of technical details very, very, very soon. Okay, welcome to my session about event sourcing in Node.js. Event sourcing is a subject that I'm very, very passionate about because it's a design pattern that helped me to do a lot of scaling in my applications. So I hope you're gonna hear this session and enjoy it. So first, I would have to present myself because this is an obligation. All right, so, well, my name is Tamar. Well, my biggest passion is to write code. I'm a software engineer for more than 10 years. I manage also large development teams, and I worked as an architect for several companies. Currently, I am a backend team leader at a company called XM Cyber. XM Cyber is a really cool startup in the security area. And what we are doing is we are simulating the activity of a hacker. I mean, we are inside of a computer network and we are running a lot of simulations to understand whether a hacker can access the valuable assets of an organization. A lot of algorithmics, really cool stuff. I was a CTO of a startup of my own, and I'm extremely passionate about Node.js. My interest in Node.js has started when actually I had founded a startup of my own where I served as CTO. And well, in that point, I wrote my entire backend in Node.js, which was very, very, very cool. And that's where I fell in love in that technology. And I got really deep into it. And that's it. So currently I'm really into Node.js. I'm specializing in performance and security. I am familiar with the engine internals. That's it actually. And another other fun facts that I would like to tell about myself is that I have 3 kids. I am a community leader at well, in JavaScript Israel. That's also like a group that organizing a lot of meetups in Israel, and we have a lot of great meetups if you're in the area. So please come over. And also I love to play my violin. Now, after I've spoken a lot about myself, I want us to write Twitter. I suggest that I hope that all of you are familiar with Twitter. So let's think about what do we need? Which objects do we need in order to write Twitter? All right. So what do we need? Let's think about a really, really simple scenario. I mean, let's not talk about images. Let's not talk about videos. Let's just think about like I'm following someone. He's following me back. I have a news feed and I can see tweets. And let's see that a tweet would be combined from a text only, and that's it. So in that case, what do I need? So first of all, I probably need a user object. An object with like username and first name and last name and other metadata that I would like to save on the user, I don't know, description, whatever, age, and etc. Then I would probably have a tweet. A tweet would be, something which is combined from a text only. And that is something which is combined from text, let's say, because we're taking the simple scenario. So I'd probably have a field of the tweet ID and the text. And what else would I have? I have to, users are tweeting, so I have to connect a user to a tweet. So I would probably have a connecting table of a user and a tweet that are connected together, like tweet ID and user ID. I would probably have that. Cool. And well, that's it. I can't think about anything else. I mean, there are a lot of stuff, but we're taking a really simple case. Oh, I would also probably have like likes. If I'm liking a tweet, then I would probably need to create a connection between a like and the tweet. So yeah, we spoke about several objects. So if we're talking about relational DB specifically, then that might be my DB schema. All right, I have a tweet, and in the tweet, as you can see, I have an ID and a text and a user ID, and the user is probably connected to a tweet somehow, because I would have the connecting table of, you see tweet is, I have a user ID, so the user is connected to a tweet, and then following, like users are following another. So look at that table of the following. So I have user ID and I have, let's call it followee ID, like who's following who. So there is a connection over there. And we're continuing with the relational DB, and I have the likes table. In the likes table, I have like user who's connected to a tweet, and we're retweeting. And also I have a connecting tables for the retweet. So this is a really complicated DB schema. So if we want to build a newsfeed, so we would probably have to take all the, for specific users, all the tweets that are related to the users that this user follow. And I'm gonna link about 5 tables in here, or I don't know, at least 5 to my opinion, and generate the query, and probably limited with, let's say, 100 tweets. And to my opinion, we are going to get with something like this. You see this query with, I have 2 joins over here over my database, and who's following, and the limit, and I have 100 limit, and that's what I'm getting. And the question to you is how this is going to scale. Well, yeah, if we were like talking face to face, and I was not talking from my home, then, you know, there would be some shouts from the audience. But how that is going to scale, not that good. Not that good. So what we are going to get is a lot of users bumping the computers into the you know, the screen, and really angry, and want this thing to, you know, to be uploaded, to see their Twitter newsfeed, and they're not going to see it. All right, so after we've spoken, and that is like you know, the gift that I have here, because yeah, that user is pissed off and he's waiting. So after we spoke about that, after we spoke about that, let's talk about why this is happening. Why this is happening. So let's talk about traditional software architecture that was very common, still very common in several places. So we have a client, and you can see it here. And the client is talking to a server, and the server is actually editing the DB. I mean, what's happening usually is I have a model. Let's take the user model. The client is registering a new user, so he's registering that to the DB. He's adding it to the DB. If he's editing the user, he's editing in the DB. So the server is doing a lot of operations in the DB. And usually the same place that you know, is serving you for writing is serving you also for reading, for querying. I mean, if I have a structure, a data structure in my database, whether it's relational or NoSQL, of users, that I would use that collection or table or whatever I'm using, or index, I would use that in order to like insert new records and query the records. So I would have you know, the same place inserting and query, like view and read. And that's like the source of the problem, and I would like to explain why that is the source of the problem. Let's take that user table, which is very common. So I have a username, and the username can be John Smith, can be Tamar Stern, and can be, well, actually Uri Shaket is a friend of mine, so I have username, I have first name, and I have last name. And well, I have these three columns in my table, and let's say that I would like to create an index on the column of first name for a specific query. Let's say that I have to query all the documents by first name. All right, this is cool. Let's say that then I would have to create an index by last name. So I have two indexes right now in my table, by first name and by last name. This is cool. And then let's say that I have to create an index by first name and by last name for another query. I have another screen, and I would have to create an index by both of them, by first name and by last name. But the first name has to be the first in the index. All right. So that is starting to be heavy. We have three indexes on the table, and think about that on every update, you have to update those indexes. And, you know, then, you know, I would have the fourth query, and then I would need to index by last name and first name, let's say, but then last name would be like the first in the index. The last name would be like the main field in the index. And then I have a crash. So I have a table with too many indexes. I mean, every database that you're going to work with have indexes, but then I have too many indexes. And well, those indexes starts to collapse because this query wants this field first, and the other query wants another field first. And eventually, the conclusion here is that you can't optimize to everything in the world. If you have one data structure, then it cannot be optimized to every query that you want to run on that data structure. You would have several queries that won't be optimized because too many indexes would cause your database to only update indexes. So that is the source of the problem. Now, I would like to introduce you another really frustrated system administrator, another really frustrated character in our story. And the frustrated character is the system administrator. The system administrator is really frustrated because he doesn't have any, let's call it, backups on what he's doing. And every migration for him is really hard. I mean, because you have to preserve the data and restart it and recreate it and add fields while migrating. So yeah, so the system administrator is really frustrated. So that is another character that we have to know. So now, after explaining to you the source of the problem or the field of the problem, let's talk about possible solution that can help you scale. And that solution is called event sourcing. So to understand event sourcing, we have to first understand the pattern itself. What is event sourcing? So event sourcing is actually a private case of an architecture pattern called CQRS. You're welcome to search for CQRS online. But what those patterns are about is separating the data structure for read and for write. Meaning that if I'm writing new data, I'm writing new records, I am writing them to one place, and then I have some kind of a background process that actually transform them into another data structures, like into another structures that would be really optimized for reading, and even can transform it to another database. It doesn't have to stay in the same database. For example, I can, I don't know, I can save like log files, and then I can transfer the data to Elasticsearch to a specific index in order to be able to search by text in the most efficient way possible. So that is event sourcing. Another thing which is very important in this pattern is actually that all of the writings would be modeled as actions. And then the effect is a huge event log that tells us what were the actions in the in the system itself. Let's take Twitter, okay? All of this lecture, we're going to think about Twitter in our mind. So let's take Twitter. What does it mean to model everything by action? Meaning that if I'm like adding a new user, then I have a record which is like action create user, name, the username, and description, the metadata. If I'm gonna have like a user which is following another user, then I would have like a record of following user follows, and then I would have user ID of the follower and the user ID of the followee. So everything would be modeled by action. So yeah, that is what's important here. It means modeling your data as a sequence of action of events, meaning that each action is considered as an event. Events are stored and append to the store. You have a storage which is an append only, and this event log could be like very big, and it would have all the actions that happened in the system from the beginning, And then if you like replay it from the beginning, you can get to the current system state. And then you publish it to consumers. So that is event sourcing. Now I would like to show you the event log. I hope that my explanation was clear, but that is, we've spoke about actions. That is taken from that is taken from a database that implements event sourcing of a system that implements a Twitter-like system. So let's look at it. We have the first action, which is follow user, and we have ID of the first action, and that the user ID, that is the user who actually performing the action. That user is saying, I'm going to follow another user. And you can see here that actually this is the user that we're following. That is the user ID that we're following. So we have follow user, the person who has done the action, and the user that he wants to follow. Let's look at the second action. We have another action of post tweet. Look at the entire records here. You see that all the records have the same structure. You see every record has an action, have a user ID which performs the record. It has like metadata. In post tweet, we have a text. The text is I'm tweeting. That is the record itself. Well, and then let's go to the, second action is like the first. It's follow user, but imagine that you can implement everything in here. If you want to implement like tweet, then your action would be like tweet, and you would have the ID of the person who's doing that action, and you have the tweet which is liked of that person. What we're doing in that case, actually, so we have somebody who's writing the events all the time to the event log. How do we publish the events? It really, really depends. There are multiple ways to do it. In the simple way, well, the event log is going to serve as a huge database log style, and we would have a lot of consumers that are going to take the data and transfer it to something else, to another data structure, and just save it in a completely different place or in a completely different collection. But that is what's going to happen in the first phase, which is like the basics of event sourcing. We're going to make it more complicated later. Now, I would like to show you a little bit of code that was written in a system that is implementing event sourcing. And we are going to implement it in the most give me a second, maybe I'll stop that. Well, let's go over the code. Let's see what's going on here. But that is a server that is implementing event sourcing. It is written on Express, and I hope that everybody in the crowd are familiar with Express. Express is a library of Node.js that is Express is a library of Node.js. I think that every developer is starting to develop from Express. That is the first tutorial that we're all doing. So let's just talk about it, and let's talk about the flows. So I would like to first of all show you the server.js. So that is the code. Here we have a lot of controllers. I would like to say another thing, that all of this server is actually implemented in a pattern of MVC. So we have a list of controllers, we have a list of models, and a controller is, the REST API is using a controller, and the controller is using a model. So that is, that server.js, and that is cool. And let's look at here at what this exposed. First of all, this is the most important route here. This is the event route. And if we want to write new event, we have a post event. So we're just inserting a lot of post events here. And if you want to see the entire events that we have in the system, we have a get event. Now, actually, we can get an event by ID, but users, we can create a new user and get a new user and get a user by ID. And here is a route of user follows. What is user follows is like indicating a user is following someone else. And here is another interesting route. This is again newsfeed. From here, we're going to get the newsfeed, and we're gonna actually now we're going to deep dive into some patterns here. So let's go into, first of all, into the event model. This is a schema of the event model. As you can see, it's full with comments. But what is important that it's generating the JSON that I've shown you in the presentation, the JSON of the several records. So here is this event here. This is the event schema itself. The action can be of 3 types: post tweet, follow user, and like tweet. And the user ID, that's the user who's doing the action, and it follows another user, for example. That is like follow user activity. The text is for tweet activity. Tweet ID is for like activity. So actually all of the other fields are metadata. So this is what like generating everything. And let's see 2 interesting models. The first model that I would like to show you is actually the newsfeed. So what we're going to get here is, first of all, for every user ID, we have a newsfeed ready. Newsfeed ready, meaning that by querying by user ID, we're going to get a bunch of documents for the newsfeed. And this document is going to get all the information that we have for presentation. Meaning that if I have, for example, I don't know, for a user like the username or the first name, last name, metadata, everything is going to be here. All the data is going to be ready in advance. Another thing that I would like to show you is like the followers. If I'm following people, I have a list of people which I follow, and here is that list also ready in advance. Meaning that by user ID, I'm going to get the list of all the users that I am following. So yeah, this is actually what's important in event sourcing is how we are going from the list of events to the users that we follow. So I would just actually show you this. Let's go over very, very quickly over the code. Yeah, sorry, it's not here. I opened the wrong file. It's here. I would like us to go very, very quickly on that code. That code is running every 10 seconds. And that code is actually transforming from the event records to the list of followers. And the newsfeed controller, there is another code that's doing exactly that. But if we can look at that, so if we're going to go to here, build user follows, so we're going to get all the events. And then we're going to get all the events that are linked as user follows. Then we're going to find all the events linked to a specific user that we're looking for. Actually, in like production implementation, we're going to get a list of users. We're going to get a list of users that are, sorry, we're going to get a list of users that we need to build this list for. So for every user of that, we're going to find all the matching events. Then we're going to, let's take one of them. And here we are creating the instance that we are adding back, that we're getting back to the client when he's going to get, when he's going to ask the, you know, the list of followers or following from us. What we're doing is we're going to the model that I just showed you, that what it's doing is like having all this list. We're going to this model, and then we're saying, all right, if we didn't find it for that user, we're going to recreate it. Otherwise, we're going to return it back. But then we're going to have here all the users. And here, what's important for you to understand is that we are creating a list of all the data that is needed for display. No joins are needed. No need to join and get the description from somewhere else. I'm just creating a document which will be suitable for everything that I want to display. All right, I'm duplicating like a lot of data here. Not a lot. Let's say like the first name and the last name are going to be here like in multiple places. But it's gonna count if, for example, most of the things that I'm doing in my system is like reads. If I'm like not writing a lot, then, you know, if I'm not updating the information of last name, so that's fine. You know, it's fine that I'm duplicating it because, you know, update would create inconsistencies. But, you know, the chance that inconsistencies would happen is rare. So let's continue. Let's continue from where we stopped. Sorry. We were here, actually. All right. Okay. What are the advantages of that method? So the advantages is that, first of all, each view has its own storage. So you can optimize exactly, whatever you want to optimize for each view that you have. You can scale up to 1 million concurrent users in that way, because, you know, you don't have like one collection that you have really heavy load on it. Each query is going to go somewhere else. Well, schema migrations are much simpler, and you have a recovery point. I mean, because you have a log which indicates all the actions on your system, you have a recovery point, which is better. Now let's talk about something that I've showed you in the presentation. So actually, you know, what we're doing is usually we're processing it in the background. You know, after saving, there would be like some time, maybe several minutes, and then a consumer is going to go take those records and like transfer the information and save it somewhere else. Those consumers are called batch consumers. All right, where to store those events? So first of all, there is a database called Event Store, which is a database which is like dedicated for event sourcing and for implementing that pattern. It's really good to search it. And if you want to go on like larger scales, you can like use a technology called Hadoop. And there is a very good there is a very good library for Node.js for contacting and for wrapping Hadoop and work with it. But what I want you, there are a lot of ways to implement it, but what I want you to remember that it's not relating to your database or technology. You can implement event sourcing on every sort of database. Like I implemented in MongoDB in my demo. The main thing is, as I said, to model your system as actions and to just write them to one place. All right, so Nest.js is also giving us a good model of Nest CQRS. And also that is also something that I really suggest to check it out. That's a very, very good model to use, the Nest CQRS. And it gives you out of the box like the entire patterns, saving an event, publishing the event. You really want to check it out. So yeah, the evolution of the architecture that we have so far. So first of all, we've saved the entities in the DB. So we've saved the state. And then we moved from saving like entities in the DB to model the actions in an immutable log. And then at the end, we have a consumers that are preparing the data offline, not when it's published in batches, and publishing it. So what's happening in the real world? So now let's talk about companies like Facebook and Twitter and LinkedIn, and all of those companies are, well, they're supporting like really large scales, really large scales, millions, like a lot of millions concurrent connections that are into that are in their website. And in these scales, well, probably we cannot like use database. Probably we have to go to things like big data technologies. So here what we need to do is something which called stream processing. What is stream processing? Well, actually, the most common technology for stream processing called Apache Kafka. I suggest you to check it out. But that means I have a lot of events that are being sent to a very strong message bus on a stream. And I have several consumers that are reading from it. Let's take the Twitter example again. So I would have a consumer that is reading the event from the stream and preparing a newsfeed. I would have another consumer that is reading the event and preparing search, for example, and another consumer that is preparing ETL processes. But if we're creating a user and sending the event to the stream, then what we're doing is the newsfeed, for example, is listening, and then it take that event and create a newsfeed object for that event. And the search itself is, let's say, saving that user in Elasticsearch as well for be ready for searches. So you have a consumer for every like action that you want to do in the system usually. You have the technology that you're usually using here are Apache Kafka. That is like very strong message bus. And you also have Amazon Kinesis, but I've worked with Kafka, so I would go with that. Amazon Kinesis is very good if you're in cloud environment. Kafka gives you a little bit more flexibility. Last note, I just want to tell you, everyone, that I've implemented event sourcing myself on a project where I have implemented a banking system for writing transactions. And another thing that I would like to say about event sourcing is that databases, for example, relational databases are actually using event sourcing in order behind the scenes, for example, in order to implement transactions. I mean, that is the design patterns that, for example, all the relational database that I'm familiar with are doing. So thanks everyone for listening. If you would be interested in the demo code or in the slide, everything is going to be on Twitter. And that is my Twitter handle. You're really welcome to follow me over there. So thank you very much. And I was very happy to be here. And bye, everyone.
Thanks, Tamar, for your amazing session. Usually the audience would now be giving you a round of applause, but maybe you guys at home can use the chat for clapping. There were questions. The first one was, do you have any experience with event sourcing and the microservice architecture? And if yes, is it well applicable?
Well, of course, maybe I wasn't clear, but like the whole design system that I've shown here is like really well. For example, you can, of course, it's applicable. Well, if you're, let me go back to this screen. All right, I hope I would, or no. So yeah, I've shown you that, right? So if we're looking at that, so actually like the newsfeed is a separate microservice itself, and the search is a separate microservice itself. Each one of them can scale out of the box itself. Or sorry, not out of the box, by using, let's say, Kubernetes or OpenShift or another orchestrator. But yes, each one of those is a separate microservice. Also, microservices are communicating with each other with, let's say, a message bus. So, throwing events to a message bus and like, having consumers, where each consumer is a microservice itself, is it's like the I don't know, most used use case of microservices. So yeah, event sourcing is very but it's very built for like using in microservice. And usually in that architecture, each consumer is a separate microservice itself. Any other questions?
Yeah, the other question was if the Twitter example code can be found anywhere, but you already said.
It would be in GitHub, of course. And I would send a link to that GitHub in the Twitter. Just follow me there, and a post would be ready, I think, after my second session, which is going to be very soon.
Third question, what pitfalls with event sourcing have you encountered and how did you deal with those? And the question is, if you can name one or two examples.
All right, so sometimes implementing the code who understand like which records to process now is hard. That's one example. Also, well, duplicating the data is good usually, but well, I've encountered like a specific case where I duplicated the data, but the collections that were created were too big. So yes, so still like duplicating is good, but beware that you don't create like too big collections. Or if the data is big, then still make it centralized. I mean, that architecture gives you like the the feeling that you can duplicate a lot of data, which is, well, it's true, but you have to be careful with it. That's another thing. Another, I don't know if it's a pitfall, but you have to maybe make sure that you don't do like over design, because it's really you know, easy to separate like everything to like really small microservices, and to at the end get with like, I don't know, 200 microservices or just too much. Make sure that you do separate by responsibility. For example, just, you know, because you have a consumer for everything, so sometimes you think that it's good to like separate everything and have like a lot of different components, and you create too many components. But eventually, like, this pattern is like really good at creating the not creating that solving scale problems. Very, very good. Another thing is that you're going to create a lot of DB schemas, and maybe you will even store things in other DBs. Like search, I would recommend to go to Elasticsearch, for example. So yeah, you would have a lot of components. You have to make sure you have a lot of good documentation. That's it. But yeah, that pattern is really helping on getting into large scales.
Okay, another question. How do you provide high availability and prevent single source of failure in a system wherein events should only be sent once to another system?
I would back up them. I mean, that is the only thing that would, well, yeah, the thing in event sourcing that you have a single point of truth, and that is like the, you know, the event log, your huge event log that you have. Well, usually in the implementation, what you're doing is that first you're writing to the event log, and after you wrote to the event log, like that's considered as a truth to you. So once it's written over there, if they're sent once, well, in my last example, I've shown like Apache Kafka. I would do like share screen another time, and we'll go again to that diagram. Sorry, that is a play button. Cool, play button. So yeah, that is like, here you probably have like, this is sent once to a lot of consumers, that is internally, but usually you always have one consumer that is like saving all those events, like saving raw events. You always have, if you're working with like Nest.js or Kafka, you always save raw events. So yeah, so if you just have like events that are sent once to another system, I would just put another consumer over there to save the raw events. This is an example of events that are sent once internally, but just internally. Just imagine that every like event over here is arrived to the Kafka, message bus, and is taking is sent once to that Kafka actually. So yeah, I would always have a consumer that is saving raw events to somewhere, to whichever data store that I want to save it.
All right, that's it. Thanks again, Tamar, for your great session. Thanks for attending. And you guys at home have a nice time at our conference. You too, obviously, Tamar. I'll see you around later. Your next talk is at 3 p.m. Central Europe time, Central European time. So yeah, please do not forget to rate this talk in Swapcard. You guys will get a notification to rate it. I think there's a 5-star rating system. And with that, I say thank you.
Okay, bye-bye.
Bye.